Volker Markl, Director of the Berlin Big Data Center. Smart data, bridging the talent gap.
Okay. So essentially what you have seen here is that what I want to make as an analogy, we are still in the stone age of data management and of data science in general. And the reason for that is that you have heard a lot of times already from previous speakers that we're really lacking the talent. We really have to make the tools easy to use, was mentioned in the keynote by Professor Greengard. And there's a huge problem with that we face right now. There's a multitude of tools, and the world has become very complex with what we call digitization and what we call data science. Because what has been happening is we have, on the one hand, data analysis, which Klaus-Robert Müller has talked about a lot, the one side of the coin, which is really the complex algorithms, really the mathematical, statistical concepts of machine learning, of mathematical programming, of advanced statistics, or signal processing. And those are important in order to gain insight from the data. At the same time, if we do that at scale, with large data sets, with data sets that come from sensors, like in the smart car movements, complex experiments, and so on, then we actually need to be sure that it's scalable. And some people have mentioned already things like MPI, or others might talk about Hadoop, MapReduce, or other technologies in order to speed up those computations. The problem now is that you need experts in both fields to make this happen. So we need essentially what would be a jack of all trades, a Swiss Army knife, or what in German we would call an eierlegende Wollmilchsau. That's really a data scientist, right? They have to know a lot of things, and in addition have to have some application knowledge in order to solve the problem of the brain-computer interface or in physics. So it's very hard to find those kinds of experts. And one attempt is, of course, to try to train them by going, sending them to college, have those data science educational programs. However, the problem is really we are seeing a new discipline emerging that comes by bringing together data analysis and scalable data management. And we have to make this much, much easier. And that's really the goal of what we are doing in this Berlin Big Data Center. That's Klaus-Robert Müller, myself, and several other colleagues, including Anja Feldmann, Thomas Wiegand, and also Christoph Schütte, and many more, where we are one of the 2 national competence centers in big data in Germany, funded by the federal government. And we're bringing together, on the one side, data analysis, so the algorithmic side, and the data management side. And we're trying to simplify how data analysis programs are written. So we are looking at using essentially also machine learning methods and artificial intelligence in order to automatically optimize and adapt to a hardware, to a supercomputer, to a MapReduce cluster, how those big data analytics programs are being executed. And the goal is by that to, on the one hand, reduce the cost of data analysis, of course also increase the time by which the data analysis can be created. So if you have, we call this concept a declarative language that enables you to specify what you want, not how to compute it, and have the system automatically do that. If you do that, you actually can not only reduce the cost, but also increase the time, and that's both the time the developer needs and the time that the system needs to execute that. So that's the key vision, and by that we hope to actually eliminate some parts of this black circle that I have shown to you that people, data scientists would need to know, and instead of that, the data scientist can really focus more on the problem at hand. So this is one of the key objectives, but it's really a much broader thing in this Berlin Big Data Center, because what we really need, and that's an important thing to observe, there's really a new discipline emerging, a discipline that brings together data analysis and scalable data management. So people from those 2 domains have to talk much more together. So people from machine learning need to look at the scalable side of things. People from data management need to look at those more advanced algorithms. And if we do that in a new discipline, then we will be able to make this impact that digitization needs. So we need the both together, and only then we can shape the digital future. Thank you.